The concept of storing electricity is clearly not new. Since the 1930s, pumped hydroelectric power has played an important role in providing electricity here in the U.S. and around the world. The Energy Storage Association, which is a national trade association, identifies that storage falls into four main buckets. Those are, number one, mechanical, which is where pumped hydroelectric falls. Number two is thermal, and ice is probably the most common in that area. Number three is electrical, which is superconducting magnetic energy storage and capacitors. Try and say that 4 times fast. And number four is chemical, which is basically batteries. We're going to talk about battery storage specifically, since it's getting a lot of attention lately. With the influx of intermittent renewable energy sources, the possibilities associated with it are considered key to customer and utility cost savings. In fact, industry experts believe that the combination of energy storage solutions, smart grid, and renewable energy are key for our future. You already know that large-scale wind can be very challenging to integrate into the grid because of its intermittent nature. The wind tends to blow at night when demand for electricity just isn't as high. The hope is that storage can help smooth out the variability.
It becomes an issue of how do you store the energy to make it work. Storing daylight power for nighttime usage is one thing. Storing summer power for winter usage is quite a different thing. So I think the pace of change will be different in different parts of the country.
You also know, probably even from looking around your own neighborhood, that people are using more rooftop solar as a way to lower their bills. You also know that these customers still rely on the grid. Otherwise, they'd be sitting in the dark come nightfall. At this point, there is no energy solution storage that has been proven to work with solar that provides an affordable and reliable option.
Electricity is this crazy on-demand resource. We don't have a place where we can just park it and use it later, with the exception of pumped storage hydro. And when you have, for example, say the wind pick up, well, that power has to go somewhere. So somebody else on the system has to back down. And that's typically, again, where you see the natural gas sort of in the intermediate role, coming off the system and allowing those resources to come onto the grid.
The good news is the technology is evolving. It's getting better. You can do more ins and outs. And in fact, we're experimenting with batteries here in Colorado as well. We have a project that we're doing for a microgrid where we're combining a battery and solar array. And then we have smaller projects where we're actually working with homeowners that have rooftop solar to install batteries and test how they can help with managing the system so that we can install even more distributed energy resources. We've got a little bit of ways to go, but it's good to learn the technology so that you can take advantage of it when it's cost effective.
While a lot of private companies, national labs, and electric utilities themselves continue to work on storage solutions that are reliable and affordable as well as scalable, it's still very much a technology that is evolving.